Okay, so here we go. What do we got? Worksheet 4.3, number 7, yes? All right, so in this problem, you've got these two weights hanging from a pulley, okay? One of the weights has a mass, I think it's mass A, has a mass of 2.5 kilograms. It's tied to a rope. The rope goes over a big fat pulley, and then on the other side, we've got mass B, which has a mass of 3.5 kilograms. Okay? So, the question A says, all right, the objects start 1.8, oh shoot, I did this again. The objects start 1.8 meters above the ground. So if I release them, how long will it take before the heavier one hits the ground? Good? So hopefully you guys were able to go, well, let's see, I know the displacement. I know it's starting at rest. So what other thing do I need to know in order to find the time it takes to hit the ground? The acceleration, right? So hopefully you got that one. Okay? So what we want to do is we want to find the acceleration of the system. So remember, you guys, you always start by looking at the system as a whole, all of your objects. So for us, all of our objects means box A, the rope, and box B. So that's my system. Okay? So you want to start by identifying external forces. So what do you got, you guys? Gravity. So the force of gravity on A turns out to be 24.5 newtons. The force of gravity on B ends up being 34.3 newtons. Everybody good with that? All right. I can't leave them both positive because they're not working with each other. So I got to pick one of them to be negative. So which way is the system going to go? Right or left? Right. It's going to go right. So which force do you want to make positive? Right. The one on the right. That's cool. So we're going to make this guy positive. We're going to make this guy negative. So from this point forward in this problem, anytime we are looking at the system, we're going to make this way positive and this way negative. Cool? All right. So are there any other external forces that are going to affect the motion of the system? Nuh-uh. So, here we go. Let's find the net force on the system. It's going to be 34.3 newtons plus negative 24.5 newtons, and it gives you 9.8 newtons. So that's the net force on my system, 9.8 newtons. Good? So now I can find the acceleration of the system by taking the net force on the system and dividing it by the mass of the system. So 9.8 newtons divided by, what's the mass? Everybody cool with why we're going to use the full 6 kilograms? Because these forces are causing this whole green system to move, right? So that's 6 kilograms. So divide by it, and you get an acceleration of 1.63 meters per second squared. Do we have any problems with that? I'm sorry, I just kicked G-Ben. All right, everybody's good? All right, so now we can find the time it takes, right? So now I'm going to go, oh, well, here's my acceleration. My initial velocity was 0. I want to find out the amount of time it takes to go through a displacement of 1.8 meters. So given this information and this equation, you can find the time. Capiche? So the time turns out to be, it's like 1.49 or 1.48 seconds. Question? Ooh, we're going to need that in a minute.
But like I did that instead of using that equation.
Oh, great.
And then, okay, is that what?
Badass, that's perfect, yes. Yeah, and we're actually going to need that final velocity. Okay, that's now recorded, so earmuffs, kids. All right. All right, are we all good up to here? All right, what I didn't ask you, and I wish I had, is I didn't ask you to find the tension in the ropes. Can we talk about that real quick? Even though that's not a question on the thing?
Yeah.
Is that all right?
Yeah.
Okay, so how do you find the tension in the rope? What is going on here? Oh, I see. This is left over from last hour. That's what's going on. Okay, so side note. I'm going to add this, so it'll be in the next year. Find the tension. Okay, so I guess probably worth discussing. How come I didn't worry about the tension here? Very good. It's an internal force, right? It's sort of pushing on the steering wheel. It's going to cancel itself out, right? Okay. So it's an internal force. We don't need to worry about it. So to find the tension, what I need to do is I need to choose a system for which the tension is an external force. In other words, I need to choose a system that doesn't include the rope. So there are two very good and somewhat obvious choices.
Make a free body diagram for just B.
Or
Just A.
just A. Pick one of the two objects and make a free body diagram. Okay, so let's do it. In this one, it matters none which one you pick. Okay, so I'm going to choose A. So here, actually, I'm going to choose box B because I want to point something out. So here's box B. All right, here's what we know. We know that box B has a mass of 3.5 kilograms. I know that gravity is pulling it down with a force of negative 34.3 newtons. Why did I make it negative? Because it's being pulled down, right? Remember, you guys, these sign conventions that I drew here in highlighter blue? Those sign conventions only apply to the system to resolve the issue of the pulley bending the force. Okay? But here, looking at box B, either box B is moving up or down. That's it. So, positive, negative. Cool? All right, so there's my force of gravity. What else? I know at least one other thing about box B. Say it again.
The force that's like pulling it up.
Yeah, there's a force pulling it up. What's it called? Tension. It is not 24.5. It's not the weight of the other block. Okay? We have to find it. Yes?
Would you then use the acceleration to multiply by the mass to get the net force, then subtract the force of gravity?
Yeah, exactly. So you said use the acceleration. What do you mean? What is the acceleration?
It's the 1.63.
Yeah, we just found the acceleration, right? We just found the acceleration. It's 1.63 meters a second squared. Sorta. Negative. Why is it negative? Because it's accelerating in a negative direction. So make it negative. So Tim is exactly right. Now we can find our net force by doing mass times acceleration. So 3.5 kilograms times 1.63 meters a second squared gives you a number that I've not yet calculated. Anybody got it? All right, let's see what we get. 1.63 times 3.5, you get negative 5.7-ish newtons. Good? So now what? Write the net force equation. Exactly. So here we go. Let's see. Net force is the force of gravity plus the force of tension. Negative 5.7 equals negative 34.3 plus the force of tension. So add the 34.3, and you get 28.6. There is your tension. Follow?
Follow.
Any problems with it?
No.
How do we check it? Make a free body diagram for the other box, right? And make sure your acceleration maps up. So let's do that real quick. That'll just take us a second. So here's our box A. Mass was 2.5 kilograms, right? Whoa. Ah! Oh no. My rock. Well, he's going to have to just hang out here for a minute. Okay, so here we go. So force of gravity. We're almost done, you guys. Negative 24.5 newtons. Now, What's the acceleration for this block, you guys? Positive 1.63, because it's going to go up, right? And so I can find my net force by doing mass times acceleration. So 2.5 times 1.63 gives you 4.08. I guess we can just call it 4.1 newtons. Good? And so now, write your net force equation to find the tension. Oh, wait. Oh, no. Well, yeah, I guess so. All right. So net force equals force of gravity plus force of tension. This wasn't the way I was planning to do it, and then it's the way I did it. So we're going to just do it. So here we go. 4.1 equals negative 24.5 plus the force of tension. Add to both sides. What do you get? 28.6. Why am I happy?
It's the same answer as B.
It's the same thing we got before. You guys ever watch the Muppet Show? When Kermit introduces a very special guest? He goes, "Is there a very special guest?" And then he goes, "I wish I could make that sound." All right, Abby, do you have a non-Muppet related question?
Yeah, I do.
Disappointing.
So could you also assume that your force of tension calculator was correct and then try to find the acceleration?
That was what I meant to do when I started doing it, and then I just was on autopilot. So yes, that absolutely works. So you're basically just using one number to confirm the other one. Either
Okay, so
use the acceleration to confirm the tension, or vice versa.
Okay. And how do you know which how do you know which one is incorrect, or do you not know?
If you don't, if it doesn't work out, then you made a mistake somewhere, and you got to just go back and look.
Okay.
All right, and I will also say that it's not a foolproof check, because if you made, there are some mistakes that if you carry them all the way through, it won't catch it. You know what I mean?
Right, I did that the other day. I thought, oh, well, it makes sense, and then I realized it wasn't the right answer.
Right.
Yeah.
Okay, so are we good?
On this one, or can I ask that?
Are we good on 7A?
Same.
Okay, so 7B. Okay. So that was a total side note, so let's rewind. So at the end of 7A, what we had discovered was that the time it took to hit the ground was 1.49 seconds, right? All right? So that was A. Now, B asks a really weird question. It says, how high will box A go before it stops going up? And then it says something about, notice it doesn't stop at the same time as box B, right? Did you guys understand what that meant, or no?
Yeah.
Let me do this. I just read it. Oh, no. I know, it's intimidating. Okay, so here is what we've got. We've got a heavy block and a light block, yes? Ooh, there we go. So do you guys agree that this is that, basically?
Yeah.
Okay, my masses aren't the same, but the same idea. Oh, you know what we haven't done, though, is get the pulleys on the strings. Switch that. Strings on the pulleys. Pulling a well out of a bucket. Okay. All right, so here we go. So when I let it go, the heavy one's going to win, right?
Yeah.
What I want you to do is I want you to watch what the lighter one does when this one hits the table. You ready? Did you see how it went flying up into the air?
Yeah.
This one stopped. Why? Because it hit the table. What did this one do? There's no force stopping it, so it keeps going up, right? Does that make sense?
Yes.
Okay? So we want to figure out how high up it goes before falling back down. Follow? All right, so to do that, what we need to do is this. So here's block A, here's block B. At this point, the velocity of everything is 0, right? Then they both fall, right? So block B drops down 1.8 meters. What does block A do? Goes up 1.8 meters. Okay, the time that it takes to get from here to here is 1.49 seconds. The acceleration is 1.63 meters a second squared. So we can find our final velocity, right? Just by doing VF equals VI plus AT. Follow? So the velocity at this point if you do VI plus AT, 0 plus these guys multiplied, it gives you 2.42 meters a second. So what that represents is the velocity block B had as it hit the ground. Well, that means that block A is going up at that velocity when block B hits the ground.
Wait, how did you get to 2.4?
I cheated and I didn't write it out. VF equals VI plus AT. Here's VI, here's A, here's T.
Okay.
Good? And you cool, the time was the time from part A. And the acceleration was the acceleration from part A. All right, everybody good? All right, so everybody good with that? Okay. How high, be careful, how high up is block A right now at the instant I just drew?
1.8, no, 3.6.
3.6, right? Because B went down 1.8, A went up 1.8. This right here is a total of 3.6 meters, right? Good? But now block A gets thrown up into the air, so there's going to be another moment when block A is up here, and we want to figure out how much higher it goes. Follow? So here's what we're going to do. During this interval, what's the initial velocity from here to here? VI is 2.42. What's VF going to be? 0, because it's going to stop at its highest point. What caused it to stop? Gravity. So what's the acceleration? Follow? What do we want to find? We want to find out how far up it went. Who's got an equation for me? 2A delta x equals VF squared minus VI squared. Plug and chug. Your displacement turns out to be 0.3 meters, which is not the answer.
You added to 1.8.
You got to add it to the 3.6, right? Because it was already 3.6 meters above the ground when it got launched. Then it goes up another 0.3 meters for a total of 3.9. That is a tough problem. Part A in finding the tension, 100% fair game for the test. Part B, the weird launchy thing, don't worry about it. Okay? I mean, theoretically, it's a thing I'd like you to be able to do, but I try really hard to make sure that the homework is a little harder than the test, so you'll be over-prepared rather than under-prepared. Abby and then Brianna.
Could you go over 5, just go over 5?
Yes, that was, yes. Brianna. 6B.
No, I'm sorry, not 5. I meant 6.
Oh, perfect.
6A.
Yes, so let me do 6 first since I just had 2 requests for it. And I reported 5 last hour, so it's on my website. You see the advantage of doing this, right?
Yeah.
Okay.
So 4 for like part of it. Like I got the tension right on A and B. I got the insurance for the middle part. It was like the top.
Gotcha. Yep, I know what you mean. Let me do 6 and then I'll do that. I think we have time for both. Okay, everybody good up to here? I don't know why I said that. We're good. Here we go.